All right, time to dive into the world of system design. We're checking out System Design Primer, that super popular thing on GitHub, and some notes on key principles.
It's like a cheat sheet for how the big companies make the platforms we use.
Yeah, and you don't have to be an expert to get it. So whether someone's getting ready for a tech interview or just curious about what happens when they click something online, we've got them covered, right?
Definitely. And about those interviews, these materials are really focused on acing them.
So even if I'm not interviewing, there's good stuff for me here.
Absolutely. Like they're really stress practice. It's like training. You wouldn't just run a marathon without practicing, right?
Definitely not. So it's more than memorizing facts, then.
Yeah. You got to build those problem-solving skills. They want you to try real interview questions, then compare your answers to theirs, like digital sparring.
So it's about how you think, not just knowing the right answer off the bat.
Exactly. Like, let's say you're designing something like Twitter. You wouldn't just list off tech. You'd talk about how you'd break the problem down, what trade-offs you'd make.
Because there's no one perfect solution.
Right, and that's what's cool. They emphasize that every choice has trade-offs. Like maybe you trade a bit of speed for more reliability.
Like choosing a superpower. You can't have them all.
Exactly. Understanding that, knowing when to prioritize what, that's key to designing good systems.
So think about the pros and cons of every decision.
Exactly. The examples help with this. Imagine designing an online store. How do you store data? SQL database. Or something like NoSQL.
I bet there's a trade-off there.
Totally. SQL is consistent and reliable, right? Super important for money stuff, but it can be slow with tons of data.
So then maybe NoSQL is better, even if it's a little less consistent.
Exactly. NoSQL is fast, great for lots of data and users, like in e-commerce. It's all about picking the best tool for the job.
So we need to find that sweet spot, right? Not too much of one thing, not too little of another.
You got it. And that takes us to two terms people mix up: performance and scalability.
Ah, yes. Performance scalability. I hear those a lot, but I'm not always sure I'm using them right.
Happens all the time. But these materials explain it well. Imagine you build a cool app, runs perfectly on your laptop, super fast, smooth, a dream.
It sounds great so far, but I'm guessing there's a but coming.
Of course, the but is you release it, and boom, tons of users all at once. Hundreds, thousands, maybe millions. If it slows down, crashes, freaks out, that's a scalability problem.
So performance is single user, scalability is handling the masses.
Exactly. Like a small coffee shop versus a huge stadium. Both serve coffee, but totally different when it comes to crowds.
Great analogy. And do these sources tell us how to actually achieve both? Good performance, A&D, scalability?
They do. But first, another balancing act. Latency versus throughput. Ready for more? It depends.
Hit me. I'm realizing it depends is like the system design motto.
Pretty much. So latency is speed, how long a system takes to respond. You click a link, how long till the page loads. That's latency.
So low latency is key for anything that needs to be instant, video calls, online gaming.
Exactly. Then there's throughput, the system's capacity. How much can it handle at once? Like how many operations it can do in a certain time.
So if latency is how fast you serve one customer, throughput is how many you can serve at the same time.
You got it. But here's the balancing act. Sometimes, for more throughput, you accept a bit more latency. Like a highway. More lanes means more throughput, but maybe slower speeds when it's busy.
Finding that sweet spot for what you need. A stock trading system needs super low latency, even if it means less throughput.
Precisely. And that leads us to a big concept, the CAP theorem.
Ooh, sounds serious. Like a law of the internet or something.
Almost. It basically says that in a distributed system where data is spread across multiple servers, you can only guarantee 2 out of 3 things: consistency, availability, and partition tolerance.
Okay, let's break that down. Consistency sounds like everyone sees the same information no matter which server they're on.
Exactly. Everyone's on the same page with the most up-to-date data.
And availability. That's got to be important. Nobody likes system down messages.
Right. Availability means the system is up and running, always ready, no matter what. It's about reliability when things go wrong.
So what about partition tolerance? That one's a bit harder to grasp.
It's important, though. Partition tolerance means the system keeps working, even if some servers can't talk to each other. Like a cable gets cut, isolating some servers. A partition-tolerant system handles that without totally failing.
So it's about being resilient to those inevitable glitches.
Exactly. Now, here's the catch with the CAP theorem. Network problems happen, so we have to assume partition tolerance is a must-have.
Which
And
means?
we have to choose consistency or availability. We can only guarantee one.
So it's like pick your poison. Either everyone's in sync, even if it takes a sec for things to update, or the system's always working, even if the data's a bit off.
Exactly. And this choice matters in the real world. Think about a banking app.
Okay, yeah, now it's getting serious.
Right. If you're all about consistency, you might have to block users during a network issue. Keeps the data safe, but hurts availability.
Because no one wants an error when checking their balance. Been there, not fun.
Exactly. But if availability is king, someone might see an old balance while things catch up. It's accuracy versus always-on access.
Tough choice. So how do they decide?
It's all about what the app needs and how much inconsistency is okay. Financial systems. Consistency is king. But social media. A delayed post isn't the end of the world. Availability wins.
So it depends. No right answer, just careful choices.
Exactly. That's what's exciting. It's a high-stakes puzzle.
Speaking of, how do we scale these things? Handle tons of traffic, data, all that. Right. We talked about it, but what's the how-to? How do you make a system bigger, more powerful?
Good question. The sources talk about two ways: horizontal scaling and vertical scaling.
Horizontal, like spreading things out, sharing the load.
You got it. Instead of one super server doing everything, it's lots of smaller ones working together, dividing the work. That's horizontal scaling.
Like a team instead of one strong person.
Duh.
It's a village, right?
Exactly. And it's good for a few reasons. Often cheaper than one huge server. And if one server fails, the others handle it, so the whole thing keeps working.
Redundancy is key. What about vertical scaling then? When's that a good idea?
Vertical is about making your existing server stronger. More RAM, more processing power, like giving that strong person a superpower suit.
Sounds tempting, but there are probably downsides.
There are. It gets pricey to keep upgrading one machine. And there's a limit to how much you can add. Plus, no redundancy. If that one powerful server goes down, everything goes down.
Like stuffing an elephant into a tiny car. Eventually you need a bigger car.
Exactly.
Yeah.
And in system design, that's usually horizontal scaling. But no matter what, there's always room to make things better.
And speaking of better, we can't forget caching. It's like magic for speed.
Absolutely. Caching makes things fast by storing commonly used data close by, like having snacks handy so you don't go to the kitchen every time.
Nice. So instead of grabbing data from the main source every time, the system can check the cache, saving time and effort.
Exactly. And like everything, different caching types exist, each with trade-offs. Client-side, server-side, even dedicated layers between servers and databases.
So another decision for the designer.
For sure. It's all about that balance: speed, cost, complexity. And speaking of balance, well, today we've only glimpsed the surface of system design. Trade-offs, scaling, performance. It's a huge field.
Yeah, just a taste of what's out there.
Exactly. So here's something to ponder. How do these ideas work when your users are global? Multiple data centers, different continents. That's when it gets really interesting.
Whoa, mind blown. Latency, consistency, even physics gets involved. Sounds like another deep dive is needed.
I'm always up for it. Until then, keep those brains buzzing. In system design, there's always something new to learn.